Okay, so hi everyone. So welcome back to this third video of this DigitDB playlist. So today in this video, we are going to solve this problem from Leetcode that goes by the name numbers with repeated digits. So before starting this video, if you are new to this channel, please consider subscribing the channel because there is a lot of amazing content already present on this. Most of the videos till now are related to either segment tree or the graph theory. So if you want to practice high rated problems from codeforces or Leetcode, you can try out these videos. Also, I have created the dedicated playlists here as you can see. So I have already made 2 videos on this DigitDB and this is going to be the third video. So let us get back to this problem. So the problem reads like this, that you will be given an integer n and you have to return the number of positive integers in the range from 1 to n inclusive that have at least one repeated digit. Right, so the question is quite straightforward. So let us try to understand the same with this given example here. So for the first example, as you can see that the value of n is 20 and the expected output is just 1. So if you start writing all the integers present between 1 to n, that is between 1 to 20, then you will realize that this 11 is the only integer in this range in which there is some repeated digit, that is at least one repeated digit, and that's why the output is 1 for this. Similarly, if you take this example for which the value of n is 100, then the expected output is 10. Why? Because if you try to write every integer present between 1 to n, then you will get a total of exactly 10 such integers for which there is at least one repeated digit, and they will be like this, that is 11, 22, 33 all the way till 99, and finally 100 because this 0 is also repeated twice. So that's why the output is 10 for this n equal to 100, right? And the same for the third example, that is for n equal to 1000 the output should be 262. So I hope you got this problem statement completely. And if you look in the constraint, then the value of n can be present between all the way from 1 till 1e9, which is quite high. So can you guess why is it a DigitDB problem? So if you are watching my videos, or even if you know already the basics of DigitDB, then one can definitely say that it's a DigitDB question, because what I told you in previous videos, I told you that there are 3 indicators for a DigitDB question. First, you will be given some range, and here you are given a range here, that is from 1 to n, right? So a range is given here. Second thing is that the constraint will be very high. So here the value of n can go up till 1e9. So this is the second indicator. And the third indicator is that in the output you always have to return an integer which will represent the count of only specific integers in that given range, right? So since all these 3 things are found here, so that's why it's a DigitDB question. So without wasting any further time, let's go to the blackboard now. So if you remember, then what we used to do in a DigitDB question. So since we will always be given with a range, and here we are given with this range that is from 1 to n. So this is our leftmost part and this is our rightmost part, right? So I have told you in the first video that whenever this is the case, then what we do is we apply that prefix sum technique. That is, I will pick that rightmost value and I will try to solve from 0 till this rightmost value, and then I will simply subtract this from 0 till leftmost minus 1 value, and that will give us the exact answer for that range, right? So I have already told you this thing in the first video, so that's why I will not elaborate much in this video. So same thing I have done here also. So since this is the rightmost part, so we will call the solve function for this, and then for the leftmost part we know the value is 1. So 1 minus 1 is nothing but 0, and we know that starting from 0 and going till 0 we have only one digit which is nothing but 0, and in this 0 there is no repeated digit at all. There is just one single digit which is 0 itself, therefore no repeated digit, and that's why I can say that for this function the answer will nothing but 0 only. So that's why solve of n minus 0 will be nothing but solve of n only. So that's why we will just solve for this. That's why we are not worried about this, and we need to only concentrate on this now. So once this is clear, let's move forward. So what we used to do, so since in this question also we are given a range and there can be multiple integers present in that range, and we have to check for each and every integer present in that range whether it contains at least one repeated digit or not, right? So that's why, to make you guys understand better, I'm considering an example here by myself. So let's say the value of n I'm considering here is nothing but something like, let's say 7, 1, 4, 1, 8, 3 and 9. So consider that you are given n something like this. So if the value of n is something like this, then let me also mark the indexes here. So this is the 0th index, 1st, 2nd, 3rd, 4th, 5th and 6th. So this is n, and these are the indexes corresponding to the digits, right? So since a total of 7 digits are present, so that's why what I will do, so you must have guessed, I will draw 7 independent blocks, right? Let me also write the indexing here. So this will correspond to the 0th index, 1st, 2nd, 3rd, 4th, 5th and 6th, and after this index, when we will cross it, then we know what will happen. So what will happen is nothing but the index value will become equal to nothing but 7, right? And also 7 is nothing but the size of this integer, right? So the size of the given integer, let me write it here, the size of this n is nothing but 7 only. So this is one thing. So keep this in mind, that the size of the given n is 7. And you also must be knowing that what we used to do initially, so initially whatever the given value of n will be there, we will convert it into a string so that digits at a specific index can be accessed by using that index, right? So that's why whatever integer will be given, we will first convert it into a string using the HTL function. So our next task is always to start from the left side and start filling the blocks and move towards the right side, that is from MSB towards LSB, as long as we do not reach this 7, that is the whole integer is completed. So whenever we will reach 7, then we will conclude that the integer that should have been formed recursively is successfully formed. That's why as we will move forward, the value of index will get increased by +1 every time. So that's why, since index will change every time as we will move forward, so that's why I can say that this index will be my one of the states. So let's call it my first state here, right? So this is very common state in digit DB problems. And now if I ask you what should be the second state here, so if you are already familiar with these questions, then you must be knowing that the second state is nothing but tight, which will help us to decide whether we can place a certain digit at an index or not. So let me explain you briefly if you're watching it for the first time. Although it is not recommended that you should watch this video directly, but even if you're watching, then I will try my best to tell you in short time. So type is nothing but a bool variable that can either contain a value of false or true. So whenever it contains a value of false, that is tight is false, that is the condition is not tight, that is the condition is loose, that is we are free to select anything from 0 till 9. So let's say you are standing on the 0th index and we know that in the original string the value is 7, right? So that's why whenever we will want to fill this block, we have the option to fill it only from 0 till 7. We cannot select 8 or 9, because if we select 8 or 9, then this whole integer will definitely cross this rightmost limit, right? Which is not true, which we do not want at all. That's why we will never place 8 or 9 at the first block. We can only place till 0 till 7. And in that also there are two cases. So let me write it here. So what I'm saying is, this is the first case and this is the second case. Why? If I decide to fill this 0th index block here with any of the digits present in this first case from 0 to 6, then if I do it like that, then what will happen is, for the remaining blocks, I will have the liberty to choose any digit from 0 to 9 for all of these blocks, right? So it will be true for each and every continuous block present after it. But if I choose this 7, which is actually present on the 0th index in this string, then it means that for the next block, I am not allowed to choose anything from 0 to 9 freely. I have the restriction now. That is, I can only select between 0 till 1. I cannot select any integer greater than or equal to 2 anymore. Because if I do that, let's say I selected here 7 and then I selected here 2. then this whole integer will definitely be greater than this, which is not true or which should not be true. So that's why I have divided the possibilities into two cases. That is, if I choose this first case, then the value of tight for the remaining section will become false. So keep this in mind, right? But if I select this, which is nothing but the actual digit present in the string, then for the next block also, whenever I will pass the recursive call, then for the next block also the condition will remain tight as before. So if it was previously tight and currently I have chosen the upper bound, that is the original digit present in the given string, then for the next call also the condition for the tight will be true. So that's why this tight will be our second state, which will be very important. We can never ignore this here. Once these two things are clear to you, so let me write all the states separately here below so that you can understand better. Okay, so till now we have these two states, that is the index and the tight, right? And this index is an integer type and this tight is nothing but a boolean type. So keep this in mind as of now. Let us now try to understand the next state, because these two states are obviously not enough as of now, because we want to determine whether a digit has already been repeated or not in the past, right? That is, suppose I am present at this block, and if I am present at this block, then I should have the knowledge whether till this point is there any digit repeated or not. So suppose here I picked 6. Let's suppose I picked here 6, that is from the first case. Then I had the liberty to pick anything in this range from 0 to 9, right? So suppose here I picked 1 and again here I picked 6. So if I picked 6 here and previously also I picked 6, then whenever I am present at this block now, then already 6 had come 2 times, right? So that's why I should be knowing whether some repetition has already occurred in the past or not. Got it? So that's why whenever we will be standing at any block, we should know whether some repetition has already occurred or not, or whether by choosing the current digit of the given block, that is on the block that we are currently standing, is that digit already occurred in the past or not. So suppose here I chose 6, here I chose 1, here I chose 2, and here again I chose 6 when I am standing at this. So if I am choosing 6 here, then I should know whether 6 has already occurred in the past or not, so that whenever the whole integer will be completed, we will be able to return a 1. That is, we will be able to add +1 to our answer, because there is at least one digit which has been repeated. So that's why it is very important for us to know whether some digit has already been repeated or not, right? So that's why we will have our third state now, which we will call it something like repetition. And this repetition will also be a boolean value only, right? That is, this repetition can either be false or true. So if repetition is false, it means that whenever I am moving forward and the current block I am standing, then previously that block there has been no repetition of any digit. But if I am standing on a block and the value of repetition is true, then it means that already there is some repetition in the past. And that's why we would have got at least one digit which has been repeated, and that integer which will form ultimately will contribute +1 to our answer, right? So that's why this repetition will be our third state, which is very important. But the thing is, how we will keep track now that what digits are already been placed or what digits are already been chosen. So since I said that I will be choosing here 6, right? So if I chose here 6 and then here I chose 1 and here I chose 2 and again here I chose 6, then how I will know that if I am choosing 6 here, then I have already chosen 6 before. So I should have the previous information, right? So what you can do is you can use something like a map. So what this map will do, so this map will increase the count of encountered digits by 1 every time. So initially the count of every digit will be 0. So suppose when I chose 6 here, then I will say that in this map increase the count of this 6 by 1, right? So in this way the count of 6 will get increased by 1. And when I will be choosing 6 next time, I will just check in this map whether the count of 6 is positive or not. So if it is positive, then it will mean that I have already chose 6 before, and that's why if I choose 6 now, then the condition of repetition will turn true from the next block onwards, right? And it will contribute +1 to our answer, whatever the digit will be found by the end. But this storing using map is not very feasible, because this map idea will only be helpful if your solution is recursive, right? But when you will try to memoize your solution, then you should have the knowledge of whenever you're standing at a particular block, then what was the condition of that map, right? And since we know that since the constraint is very high, then we definitely have to memoize the solution by the end. So that's why using a map is not very feasible to store the data. So that's why we will not use a map, right? We will not use it. Instead, what we will do is we will create a mask here. So some of you must have guessed it by now. Why is it required here? As you can see, what I have done here is I have created a mask here. So this mask is nothing but an integer variable only. So that's why it will have 32 bits, right? So here I only have drawn 10 bits, that is from 0 to 9. So it will go up till 31. So let me write here. So this will go up to 31st, and we know this. And initially the value of this mask variable will be 0. That is, each and every integer present at every bit will be 0, right? So if I write here, then the value of this 0 will be 0, the value of 1 will be 0, and the same will be true for each and every bit. Why? Because the value of this mask integer variable is 0. So that's why every bit has to be 0 only. So the same will be here. So now if you remember, then what we wanted to store the data of already encountered digits. That is, if I suppose chose here 3, then when I will move to the next block, then I should know that I already have encountered 3. And suppose here I chose 2, then when I will move to the next block, then I should know by standing here that I already have encountered 3 and 2, both of these. So to make this possible, we will use this mask. So now what we will do is, when we had the liberty to choose anything from 0 to 7 and we decided to choose, let's say 3, right? So we decided to choose 3, that is the value of digit was 3. So what we will do is, in this mask variable, for the third bit, we will turn it on. That is, initially it is turned off, that is the value is 0 at this bit. But if we chose the digit as 3 for the first block, then we will turn it on. So now the value will be here nothing but 1. Then we will move forward and we will reach this block. And since I chose here 3, so let me mark. So here I chose 3. And now I am standing on this block. So since I am standing on this block now, so let me mark the same. So now I am standing on this block. And now since I have chosen 3, then we know that here I can choose anything from 0 to 9. So suppose I decided to choose here, let's say 2. Let me write the same thing here. So I had the liberty here to choose anything from 0 to 9, right? So I could have chose anything from 0 to 9. And this will just be a one case and not two separate cases, unlike before. Here what I have said is, I will be choosing 2. So whenever I will be choosing 2, then I should know that whether I have already chose 2 before or not. So that's why we will look in this mask at the second bit, whether its value is turned on or off. So if the value is 0, then it means that we have not seen it before. That is, we are filling it here for the first time, right? But if somehow the value was 1 for that bit, then it means that we have already encountered it in the past, and that's why we have updated our mask like that. And if that was true, that is, if the repetition was found, then for this third state, that is the repetition, we will mark it as true from the next block onwards, because by now we must have found at least one digit which is repeated, and the value of repetition will be true for the whole next part, right? So till now the value of repetition was false, right? So let us now move forward and try to fill the next block. So now we are standing at this block, and now again we had the liberty to fill anything from 0 to 9, right? So again we can fill anything from 0 to 9. And now suppose I decided to fill it with 3. So if I fill it with 3, let's say, right? So what will happen? So till we reached here, we know that the value of repetition was false, because first we filled it with 3, then we filled it with 2. So that's why when we reached here, then there was no repetition present previously. But now, since we have chosen 3, then we will see in this mask for the third bit. And sorry, I forgot to update this mask when I moved from this iteration to this iteration. So this 2 will also be turned on now, right? So sorry for this. So now since I have chosen 3 here, so I will see that whether in this mask for the third bit it is on or off. So clearly for the third bit it is on. and since it is on, it means that we already have chosen 3 before. That is, we already have chosen 3, right? So whenever we will move to the next block, since this block till the last block, the value of repetition will be true, and we will just see at the end if the value of repetition is 1 or not, that is true or not. So if it is true, then it means that there is at least one digit which has been repeated, and that's why whatever the integer will be formed, we will consider it as a valid integer and it will contribute +1 to our answer. So let us now try to fill all the blocks one by one with the same logic. So that's why, since here I have chosen 3, right? So again we will try to mark this third bit in this mask as on, but it is already on, so we don't need to do it again. And even if you do it, it will only remain as 1. Right, so we are done with the third block, that is the second index, and now we will move forward, and by doing that we will reach this block here, that is the fourth block or the third index. So again I had the liberty of choosing anything from 0 to 9, right? This is just a one single case because we cannot split it into two cases, and why I already have told you. So now suppose we chose any integer, let's say we chose 4 here, right? So suppose 4 was there and we chose 4. So if we chose 4, then what will happen? And also now we know that from onwards this block, the repetition value is true because we have already encountered 3 twice. So the repetition will be true for this whole part now. So the repetition will be true, right? So what we will do is we will again check if this 4 is already marked, if this 4 is already been marked true or not in this mask. So for the fourth bit it is off. So what we will do, we will turn it on, right? And then we will move forward, that is we will now be standing at this, and since the repetition was already true, so that's why no matter if this bit was already turned on in this mask or not, because we already have found one such digit which was already marked on in this mask, and that's why the repetition will again be true for this block. And since the repetition would always be true for the next block, so that's why no matter what digits you choose at this block, you always have to contribute +1 to the answer, no matter what integer will form, because whatever integer will form, it will always be formed in this range only, that is from 1 to n, which will have at least one repeated digit. So that's why let me do these things quickly. So again here I have the choice of choosing anything from 0 to 9, right? So let's say now for this case, that is for this block, that is for the fourth index, I chose 9. So if I chose 9, then what will happen? So I chose 9, and by choosing 9 I will check in the mask whether it is marked as true or not. So for the ninth bit it is off. So what we will do is we will turn it on, and by turning it on we will know that we are encountering this 9 digit for the first time, right? But since we had already found at least one digit which was repeated, so that's why when we will move to the next block, the value of repetition will be true only and not false. So now again we will move from this block now to this block, and again we will have total 9 choices from 0 till 9. So now suppose I chose 7, right? So if I chose 7, then what will happen? So if I chose 7, then, and again this is just a one single case and not two different cases. So now we will check whether this 7 has already been present in this mask or not. So if you look in the 7th place, then it is turned off. So we will turn it on. So after turning it on, we will now move to the next block, that is the last block, and now we will be standing here with the repetition value equal to true, because there is at least one digit which has already been repeated in the past, right? So again we had the choices of filling everything from 0 to 9, and now suppose I chose 8 here. So now again I will look in this mask whether for the 8th bit it is turned on or off. So since it is turned off as of now, so what I will do is I will turn it on, and then simply the value of index will get increased by 1, and once it is done we will be standing at 7 now, and whenever the value of index will become equal to the length of the given integer, we know what will happen. So now the value of index is 7, right? And also the size of the given integer was 7, which is matching now. So in this way we will conclude that the integer has been formed successfully, and now we will just check if repetition value is true or not. So if repetition value is true, then we will conclude that there is at least one digit which has been repeated, and that's why we will return a +1, which will contribute to our answer. So this is the whole thing. I hope you understood. So that's why, since the status of this mask can be different for a particular block, That is, when we are standing at this third block, that is the second index, then only this second and third bit was turned on. Similarly, when I was standing on this fourth index, then the status of 2, 3, 4 and 9, right? So the status of 2, 3, 4 and 9 was true, that is turned on. So that's why this mask will be our fourth state. So this mask will be our fourth state. So I hope you got every point till now that I told you, right? If you're facing problem in understanding, then you must watch the video again. I won't say that it is very hard to understand, but yeah, if you're watching it for the first time, then you might face some difficulty. That's why it is advised to watch this series from the beginning, right? But still, I'm trying to make you guys understand everything by making this the diagrams as much beautiful as possible. Now the thing is, what do you guys think? Are these 4 states enough, or are we missing out something? Let's think. So here I have considered this third state here, that is this repetition state, right? But let's take a case when this repetition third state will fail, and we already have did something similar in the first video also, if you remember, and you must have guessed it. So we know something as leading zeros, right? So let me draw these things in a separate place. So again, let's consider a total of 7 blocks, and I'll be quick this time in order to make you guys understand this fifth state, that is the leading zeros, and why it is also necessary here as before. So consider that you have these 7 different blocks, right? So we know this. After this, the value of index becomes equal to the length of integer, right? So since the value of n originally I took was 7141839, so initially the value of 1 that I took was 7141839, right? So we know that for this first block we can choose anything from 0 to 7 because initially the condition was tight, right? So suppose from this 0 to 7 I decided to choose 0. So let's write 0 here. So I have placed 0, and when we'll move to the next block, then since no repetition has occurred, so that's why till now the value of repetition will be false for this block, that is the second block, that is for the first index. And since I have chosen 0 here, it means that now for the remaining part I can choose anything from 0 to 9 for each and every block, right? So suppose I again chose 0 here. So if I again chose 0 here, because I am allowed to choose this, then the question is, for this next block that we will move in the next iteration, what will be the value of this third state, that is this repetition state? Will it be true or false? Because we know very well that our actual integer has not yet started forming, because it will only start forming as soon as we start filling a block with a positive integer, that is a non-zero integer. But since till now each and every digit that we have filled it is nothing but 0, so that's why our actual integer is not yet started forming, right? So that's why if we only rely on these 4 states, then what it will do is, in this given mask, that is the mask that I have considered, for the 0th bit it will first turn it on, right? So for the 0th bit in that mask it will turn it on as if the integer has been started forming, but we know that this is not true, right? So we don't want to update the mask as long as the leading zeros are present, right? So let me write this point here because it is very important. So we don't want to update the mask as long as leading zeros are present, right? So as long as leading zeros are present, we know that our actual integer is not yet started to form, so that's why we do not want to update the mask in that case. So that's why we will have our fifth state here, which will be this leading zeros, which will help us to determine whether leading zero condition is true or false as of now for standing in a given block. So since initially the value of leading zeros was true, that is each and every digit present before was 0, and again if we chose 0 here, then when we will move to the next block, the condition for leading 0 will again be true for this block, right? And again if we choose 0 here, then when we will move to this block, then the condition for this block for the leading 0 will be true because each and every digit present before it is 0. But as soon as we fill it with a positive integer, let's say 1 here, so if I fill it with a positive integer, then the condition of leading 0 will break, and that's why when we will move to the next block, then from the next block till the last block, the condition of leading 0 will turn to be false, right? And another problem that can have been created if we do not use this fifth state of leading zeros is that whenever I filled it with 0 and moved to the next block and again filled with 0, then it will see that in the given mask, yes, the mask that I have considered for the 0th bit, it would have turned 1, right? And again if I filled it with 0, then it will see that for the 0th bit it is 1, that is the repetition has occurred now. And that's why from this next block onwards till this last block, the value of repetition will be set to nothing but true. But suppose we filled these blocks something like in this fashion, let's say 1, 2, 3, 4 and 5. So when we will be present at the 7th index, then the status of integer will be something like this. So it will represent nothing but 12,345. And we know that in this integer there are no repeated digits, so it should not contribute +1 to our answer, right? It should not contribute. But if we do not use this 5th state, then it will see something like this 0 is repeated twice, and that's why it will contribute to +1 to our answer, which is actually wrong. So that's why this leading zeros concept is again important here as our 5th state. So I hope you got this. And if you think carefully, then you will realize that these 5 states are literally enough to create any integer for the given question. And these 5 states will always be able to handle each and every integer without any error, right? So let me also write the second problem that we could have faced, as I told. So if we do not use this 5th state of leading zeros, then what can happen is if 0 comes twice, then the value of repetition can be turned true. And if the integer is formed something like, as I told you before, that 12,345, in which no digit is repeated, but it will treat it as if it is repeated because of these leading zeros. So that's why whenever leading zeros will be present, we will always pass the value of this repetition as nothing but 0, right? So we will always pass it as 0. So keep this in mind. So now I think I've explained you each and everything in very detail, right? So let me give you a summary of what exactly happened in this question. So since in this question we wanted to count the total number of integers present in a given range in which there is at least one digit which is repeated, right? So that's why, since we had to construct our integer from the most significant bit towards the least significant bit, that is from the leftmost side towards the rightmost side, that is going in this direction. So that's why the value of index will get increased by 1 every time. So this is our first state. And since we had the option of choosing some digits at a given specific position from 0 to 9, so this type will help us to decide that. So that's why this is the second state. And since by standing at a given block, we want to know whether this integer has whether this digit has already been seen previously or not. So how we will know it? We will know it by storing the previous data, that is the digit we have already encountered, by turning the bit on in the mask. So that's why this will be my another state. And whenever we will reach the end, that is the value of size of integer will become equal to the index, then we will just check if the repetition value is true or not. So if the repetition value is true, it means that there is at least one digit which has been repeated, so it will contribute +1 to our answer. So that's why this repetition will be my another state. So a total of 4 states as of now. And since if we use only these 4 states, then what it will do is whenever we will encounter leading zeros continuously, then it will first update it in the mask, which we do not want because we know that the integer has not yet started to form. And the second thing is that it will treat that continuous zeros as repetition equal to true, and it will propagate it to the next blocks. And by the end, if some integer like 12,345 has been found in which no digit is repeated, then although no digit is repeated, it will still contribute +1 to our answer, just because this repetition value got true because of these leading zeros. So that's why whenever leading zeros will be present, as long as the leading zeros will be present, the value of this repetition will be nothing but false, right? So as long as the value of this leading zero will be true, that is the integer has not yet started to form, then it means that we do not want to update the mask, right? So let me write here. So if it is true, that is leading zeros are present, then it means that our integer has not yet started to form. So this mask will be 0. And also no repetition has occurred, so this will also be 0. So I think I have explained you each and everything in very detail till now, and nothing further concept is required in this problem. So now I think it will be very good for us if we move to the coding part and actually code this up and see if we are correct or not. So let's now go to the code editor. So as I told you what we will do, so let us convert this given integer into a string, let's say s. Once it is converted into a string, we will call a function, and whatever value it will return, I will simply return that, right? And I will just pass this string s, right? So let me start writing this function here. So since it will return an integer value, so that's why this will be int, and the name of function is f, and here I have passed this string s, right? So this is my function. And now we know that initially the value of index will be 0, the value of type will be 1, right? So let me write these two things here. So the value of index will be 0 initially and the value of type will be true. So this will be bool and not int. And we also know that what will be the base case. So if this idx value will become equal to the s dot size, that is the size of the integer, then we will see if the repetition value is true or not, right? So initially we know that the repetition value is false because nothing is repeated initially. So this will also be bool. Let's call it repetition only. So at the end we will just check if this repetition value is true. So if this is true, then it will mean that there is at least one digit which has been repeated, right? So if this is true, then we will return 1, otherwise we will return 0, right? Or you can directly write it like this also, right? So if repetition is true, it will return true, that is it will return 1 and it will contribute +1 to our answer. But if it is not the case, that is, we now had the liberty to select few digits for the given index, that is the present idx. So the lower bound will be 0 and the upper bound will be decided by the value of type. So if type is true, then it means that the condition is tight, so we can only choose up to the upper bound, that is this s of idx minus 0. Otherwise we can choose till 9. And now we know what we used to do, so we will iterate starting from this lower bound for the digit and going all the way till this upper bound, right? And what I told you, so see, this is very important now. So we know that we have to see whether leading zeros are present as of now or not, right? So we'll check if leading zeros are already present as of now or not. So if leading zeros condition is true and the digit that I have chosen right now is also 0. So if both of these things are true, it means that the condition of leading 0 will also be true for the next block. That is, whenever I will call this function again, so this string will be s only and the idx will get increased by 1 and the tight value will depend. So if the condition was tight till now and the digit that I have chosen now is equal to upper bound, if it is true, then the condition will also be tight for the next block. And then repetition. So how we will decide this repetition, we will see very soon, right? And since we want to store the result, that is this, so that's why I will do it something like this. So now the thing is, see, since initially the value of leading zeros was true, so let me declare this also here. So initially the value of this leading zeros was true, right? So if it is true and the current digit that I have selected is also 0, then for the next block also the value of leading zeros should be true, right? So that's why this should be 1. Got it? And one thing that I told you is you also have to decide what will be the value of repetition for the next block, because if this condition is true, then it means that whatever digits I have chosen till now is just 0 and no repetition has occurred as of now. Since no repetition has occurred as of now, so that's why for the next block also I should set this repetition as false, that is this 0. So this, but if this is not the case, that is the condition of leading 0 was already broken before. So if this is not the case, then it means that the current digit that I have selected is a non-zero digit, right? That is, we must see in the mask that I have considered whether this digit was previously present or not. So since we have to check for this digit in the mask, so that's why I have to declare a mask here now. And since I told you that the value of mask will be 0 initially because each and every bit will be turned off, so that's why let's name it as mask, right? And I will check if this digit is already used before or not, right? And how we will check? It's very simple. We will just take the bitwise end of this 1 and we'll shift this mask towards right by this digit, right? So if this is true, it means that this digit has been seen before. So this is nothing but common maths. You can try out with any example, right? So if this is true, it means that we have already seen this digit before. So now I again want to call this recursive function here, and we know that for this will be s only, this will be idx plus 1 only, right? And since I have created a mask here, so that's why let me give a comma here, because there has to be some logic in order to determine the mask for the next state, right? So since the leading 0 here is the last second argument, and we know that for this case the value of leading 0 has turned false successfully, so that's why this this will no more be 1 but rather this 0, that is false, right? Similarly, this repetition value, so this will not be 0 but rather we have to decide what we should keep it, and the same for this mask, right? And once these three things are decided, we will just simply return our this result like this, right? So we know very clearly that if this is the case, that is each and every digit present or chosen till now is 0, then it means that our actual integer has not yet started to form, that is the value of mask should remain 0, right? So that's why we will keep it as just mask as we passed it here, or you can also keep it as 0, it will not change anything, but let's keep it as mask only, right? Because initially the mask value will be 0, so it will remain 0 if this is true. Then when I will move for the next iteration here, then for this current digit in this block, I should update its status in the mask, right? So suppose I am encountering a positive integer for the first time, that is the digit is non-zero, so this block will execute, so it will see if this is true or not. So it will see that this digit is getting used for the first time, that is it is not used, right? So it means that I have to update its status in the mask variable. So to update the status of this current digit in the mask variable, what I will say is, I will say this. So if you take the bitwise OR of the present mask by shifting with the integer 1 by shifting it with the digit bits, so if you try out this mathematically, then you will realize that this will simply update it in the given mask for the current digit. So using this digit bit in the given mask will be turned on, which we want for this case because this is a non-zero integer, right? And let us now try to decide what will be the value for this once we move from the current iteration to this next iteration. So this was nothing but our repetition, right? So this will be simple. So what I will say is, I will check if the value of repetition that I have passed here is already true or not. So if this repetition is already true, or the digit that I am present here currently with is already used, right? So if the value of repetition was already true, then no matter if the current digit was already used or not, the value of repetition would be true for the next iteration as well. But if the value of repetition was false till now, but the digit that I have selected right now is already encountered before, that is turned on in the mask, then it means that now we have found at least one digit which is repeated, and then for the next iteration the value of repetition will be turned on, and once it is turned on, whenever the next iteration will be called, it will see that this is true, and either if one of them is true, which is this, then it will simply propagate true for repetition till the last point, that is till the last block which we want. So this, so now I think I have written the code here, right? And let me zoom out a bit. So this is the code that I have just wrote, and I have explained to each and everything in very detail. So let's now try to run it to see if we are correct here or not. So as you can see that each and every test case is correct here in one go, right? So let me explain you the code again what I did. So you know the base case already, that whenever the value of index will become equal to the size of the integer, it will mean that the integer has been formed successfully, and then we will just see if the value of repetition is true or not. So if by the end the value of repetition is true, then it means that in the formed digit there is at least one digit, in the formed integer there is at least one digit which has been repeated. So we will return +1, and it will simply add it to our result, which is we are returning at the end. But if this is not the case, then it means that we are present in something between, right? That is, not every block has been filled as of now. So we know that the lower bound will be 0 and the upper bound will be decided by this tight value. So we will iterate through each and every possible digit from the lower bound to the upper bound, and as I told you that as long as there will be leading zeros, the mask should not be updated, that is it will remain 0, right? And also the value of this leading 0 will be true as long as leading zeros are present, and this repetition will be false, that is 0. But if this is not the case, that is we have encountered a non-zero digit here, then we know that once we have encountered a non-zero digit, then for the next iteration if we call, then the value of this leading 0 will no longer be true, it will be false, so 0 here. And this mask should also be updated with this current digit because the actual integer has now started to form successfully. So we will update the mask with this function, right? And also to decide whether a repetition would be possible from the next block onwards or not, we will see if the repetition is already true. So suppose if there is no repetition, but the current digit that we have selected is already present in the mask, that is this digit has already been seen before. So if this is the case, then this will return true, and then if it returns true, then from the next block onwards it will always carry true forward. So now what is our next task? Our next task is to memoize this solution, right? So let us quickly start doing it. So we know that we first have to do a meme set here. So once the meme set is done, let us declare the dp array here. So since there are total of 5 states, so I will declare these 5 states here like this, and we will check here if the value of this is not equal to -1. It means that this has already been stored in the DP array, so we'll just return this, and at the end we will also store it here. Right, so let us start now writing the name of these states. So this will be our index, and let's say this will be our type. And so let's follow the same structure as we did in the blackboard. So as I told that IDX will be my first state, type will be my second state, then repetition, mask and leading zeros. So repetition, mask and leading zeros. So this will be my overall structure for the DP array. So let me copy paste here. So once this is done, let us now try to decide the sizes for each one of them. So since the value of n can go up till 10 to the power 9, that is 1 and 9 zeros, that is a total of 10 digits, and in order to access 10th index we must declare a size of 11. And since the next state is type, which is a bool value, so 2 for this, that is either true or false. Similarly for the repetition it will be 2, and also for the leading zero it will be 2, that is. But what will be the value for this mask? So this is very important to understand. See, and this is a very crucial part also. So since the value of n can go up till 10 to the power 9, so if I show you the mask that I created before, so as you can see that in this mask, so in this mask what we are doing is we are only playing with this part every time, right? Because what is the use of this mask? The use of this mask is very simple, that is to turn either on or off each and every digit present between 0 to 9, that is in this range only. So that's why we are only worried about this range and not of this range, right? So we don't want to do anything with this range, we only need to play with this range, right? So that's why, since there are a total of 10 blocks in this range and each one of the block has two choices, either we can fill it with 0 or 1 for each of the blocks present in this range, right? So that's why, since there are a total of 10 blocks and for each block we have two choices, so that's why 2 into 2 10 times, which is nothing but 2 to the power 10, which is nothing but 1024. So a total of 1024 different states are possible, right? So let me write here 1024 states are possible. And also if I prove you this, then since you know that the value of n can go up till 1e9, so if I write it here, so this will look like this, right? And let's say I consider a number less than this because I cannot cross this, right? And since I cannot cross this number, so I'm choosing a number here less than this. So if I decrease this number by 1, then what number will be formed? So we will get this, right? That is this. Also, if I want to fill this mask that I have considered to a maximum possible state, that is, so consider a case when each of these bits here is turned on, that is starting from the 0th bit and going till the 9th bit, each and every bit is filled with 1, that is turned on. So if there is one such integer, so if we try to form that integer somehow here, then we know that this will either be 1 or 0, right? So if we select it with 1, then the remaining will be zeros only, and that's why in the mask also only 2 bits will be turned on. And since only 2 bits will be turned on, so that is 0 and 1, so that's why the state that it will use in the mask is nothing but 0 into 2 to the power 0 plus 1 into 2 to the power 1, that is 0 plus 2, that is 2. So it will use this index 2 for this digit, that is the maximum value of n possible. But let's say here instead of 1 I select 0. So if I select 0, then for the remaining digits, if I want to utilize the mask array to the maximum, then mask integer actually, then I can fill it with something like this, that is 9, 8, 7, 6, 5, 4, 3, 2, 1. And we know that till this point we had leading zeros, so our mask will stay 0 only, right? That is, for the 0th bit also it will be 0, but for the remaining bits starting from 1 until 9, the value of bit in that mask will be turned on, right? That is, except for this 0, each and every bit will be turned on. And if this will be true, then what will happen? So if I make the calculation here in front of you, then it will be something like 1 into 2 to the power 1 plus 1 into 2 to the power 2, so something like 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 all the way till 2 to the power 9. and 2 to the power 9 is nothing but 512 only, right? So this is nothing but 512. So 512 plus 256 plus 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, right? Sorry, this won't be 1 here. And if you add all this, then what you will get? So you will get nothing but 1022, right? And in order to access this 1022, you must declare a size of at least 1023, right? Common sense. In order to access this 1022, you must declare the size of the mask array as 1023. So since here I said 1024 because I thought initially that this 0th bit can also be utilized somehow, but after writing it here like this, I realized that this 0 will never be turned on in the bit, and that's why 1023 size will also work fine. So if I show the same thing here, so this will be 1023 at max, right? And if I run it, then let's see if you are correct here or not. So these test cases are true, and let's now try to submit it and see if we are completely correct with this logic or not. So as you can see that our solution is accepted, and this 1023 actually worked in my case. So that's why it is very important to break down the constraint and see what maximum possible size can be took here, right? So taking greater is still okay, but taking the size of a particular state for the least required value, it clears your concept about the problem. So in this way we solved this problem, and I told you each and everything in very detail what is the logic behind all this, right? So thank you so much for watching this video till this point. I really hope that you understood something new which can be helpful in your interviews or online assessment in future, or also in competitive programming if you are doing it. So yeah, and also if you are watching this video till this point, then please consider liking the video and subscribing the channel, because it is taking me a lot of efforts to create these types of videos in daily basis. So yeah, only if you support me, then I will be able to create these videos on regular basis for you guys. So yeah, thank you so much for watching the video. Thank you.